Hi, my name is Karim Ahmed. I'm a 31-MT student. Our project consisted of a car that moves on a line using a light detecting sensor module. The idea is that the car, that the two middle modules sense that the line is working. It moves in a straight line. If the rightmost sensor detects a line, then it turns right. If the leftmost sensor detects a line, it turns left. And if, for example, if it's moving in a straight line and it senses an obstacle, it stops using this proximity sensor. The reason that we were putting the car in upside down position is that due to the dimensions of the car, due to its low quality, isn't accurate. One motor is not as straight as the other motor, and thus it moves faster than the other. And we couldn't test it on the floor. Yep. The parts that we were using in the car consisted of a proximity sensor to sense the obstacles, a light detecting sensor module consisting of 4 sensors, an H-bridge, 2 batteries, breadboard, and an Altera board.
My name is Zayed Tare. I'm 31-MET student. Today I will explain the functionality of the H-bridge in our project. Okay, the functionality of the H-bridge generally is to convert output signals from the Altera board into output voltage signals to the motor. We have 4 outputs, 2 for each motor, positive and negative polarity. Okay, the H-bridge is connected with a ground cable, connected to a unified ground between all the components of the project. This ground is connected to the ground of the Altera. We have here the input voltage for the H-bridge kit. It's connected to a 9-volt battery. And here the cables of the outputs of the H-bridge kit. Here are the 6 inputs of the H-bridge kit, an enable signal for each motor and 2 inputs for each motor. Okay, in order to start the motor, we need to program the FPGA in order to start the motor. We need to insert a high voltage for the enable, low and high for the input 1 and input 2 in order to start the motor in clockwise direction. We can also start the motor we can reverse the direction of the motor by inserting an high-low input signals, and we can stop the motor using a high voltage signals. Thank you.
I'm 31-MT student. I will be talking about the proximity sensor, which is essential to detect obstacles in the path of the robo car. The type of the sensor is an infrared proximity sensor, which has a range of voltage from 6 to 36 volts and a range to detect obstacles from a range of 3 to 30 centimeters. The proximity sensor is connected to a battery, a 9-volt battery on the breadboard, and the ground wire is connected to the common ground wires on the breadboard, which is also connected to the Altera, the battery, the H-bridge, and the line detector sensor as well. The type is B.A.M.F. It is a digital type sensor which generates 1 when it detects an obstacle and 0 when it detects nothing. And now we can see a demonstration of the proximity sensor.
Hi, I am Mahmoud Fathi, 31-MET student, and I'm going to explain to you how the LDR works. It is connected to the extended ground node and the breadboard that it has its supply from the Altera, and its VDC supply is actually supplied from the Altera 5-voltage supply. The LDR sensors actually emits infrared radiation. When it's totally absorbed, each one of these indicates a red light. So we designed our code to have the 2 outputs in the middle lights when it has a straight line. And when the root of the car is curved to the left, for example, it has the leftmost LED lamp light.
This is Farah Musa, 31-DMET student. I'll be talking about the input and output pins. We'll take input and output from the Altera, this part, where the Altera board provides 40 pins. expansion header. The header connects directly to 36 pins and also provides 2 pins for the DC voltage. One is 5 volts and the other is 3.3 volts. There are also 2 ground pins there. First pin is pin 34, the one on top. This is assigned to the signal cable of the proximity sensor, where pins 26, 28, 30, and 32 are assigned to the signal pins on the line tracking sensor, and the 5-volt DC pin supplies the line tracking sensor power, and the pins 0, 2, and 4 are for the left motor. They're assigned to the H bridge, which supplies the right motor with power. Pin 0 is the enable right motor, and pin 2 and 4 are the N1 and N2 of the right motor. Pins 1 and 3 and 5 are basically the same as pins 0, 2, and 4, but for the left motor, they're assigned to the H bridge, which supplies the right motor of the left motor with power. Pin 1 is the enabled left motor. Pin 3 and 5 are N1 and 2 for the left motor. The ground here is connected to the breadboard over here, which is common ground for all the other devices that are connected to it.
Hello, my name is Ahmed Sidan, a 31- student, MET. I will be handling the coding part in our project, which is programmed on the Altera board in order to turn the robo car left, right, or stop it when needed. Used in executing our code. The first module, which is the top level module, is called trial. This one takes as an input prox, which is the proximity sensor. S1, S2, S3, S4 are each bit on the line detecting sensor, and gets as an output the enable 1 right, which is an enable for the right motor, N1 right and N2 right are for the right motor also. N1 left is the enable for the left motor, and N1L and N2L are the in for the left motor. These are all outputs for the motors, which are connected to the H bridge, which converts this digital signal of ones or zeros to an output voltage to the DC motor. Then we execute, we have a module for each motor. Motor right is the module for the right motor, and motor left is the module for the left motor. Each motor functions independently of the other. They both take the inputs of the line detecting sensor, which are S1, S2, S3, S4, and the proximity sensor input, which is input prox. Then the motor right takes as an output N1R, EN1R, N1R, and EN2R. And for the motor left, there is EN1L, N1L, and N2L. Now let's take a look on the motor right module. It's a very simple code. As you can see, the code is executed in the always block whenever S1, S2, S3, S4 or the proximity sensor bits are changed. Of course, these all come from the pins, the I/O pins on the Altera. If the proximity sensor is equal to 0, which means that there's an obstacle in the way of the robocar, the motor would stop, which is the right motor. Else, if the S1, which is on the right side of the motor of the line detecting sensor, if this detects a line, then it would mean that the line is going to the right, which means that we need to stop the right motor in order for the car to rotate to the right side. And there's this if, which means that there is no line that is detective. If not S1, not S2, not S3, not S4, we would stop also the motor. Else we would function the motor in its normal way. 101 is the code for the H bridge in order to rotate the wheels of the motor in a clockwise manner. The same goes for motor left, except that there's an exception in S4, which is not the same as S1, of course. As S4 is the leftmost signal, if line detecting signal bit, if it detects a line on the left, then we would need to stop the left motor in order for the car to rotate left. And same goes as the motor right for this if statement. If there is no line, then we need you to stop, else go and function as normal.